Oh my. Oh my, did I find a killer for you here. Yeah, sorry about this, folks, but that's just the way it's gonna be. All right. So let's see if we can figure this out algebraically. I think the first thing that you should do here is kind of just try to factor things, make things look a little prettier. Okay? What do I mean by prettier? Well, let me show you. First things first, you can take a 2 out. Look at that. That's going to give you an x minus 3 there. That equals to 2x. But don't forget, we can make that into a fraction. Oh, yeah. You remember that? Now, check this out. Look at this guy right here. I don't like the fact that it's a minus x. So I'm going to make it a minus x plus 3. And I'm going to factor out a negative 1. If I factor out a negative 1, this now becomes x minus 3. Just flip the signs. And look at that. Why did I do that? It's because this guy and this guy now are the same. Aha. So, check this out. This guy still is okay. All right? There's our x minus 3. Perfect. That equals 2. There's my 2x. I know it's going to be irrational, so I'm going to make it into a rational by putting it over 1. But isn't this minus minus thing, isn't that cool? That actually makes this a plus. This now becomes a plus x over x minus 3. Well, look how much I cleaned that guy up. Now, do you remember from last year? Find the common denominators. Look, this has a 2 and an x minus 3. Okay, so guess what? What's missing here? A 2 and an x minus 3. So common denominator means, guess what? A 2 and an x minus 3 goes here as well. What's missing on this last one? On the last one, you're missing just, guess what? Yeah, you're just missing this 2. So multiply that by 2, multiply that by 2. Do you remember this from last year? Math 20-1, baby. Okay, now that they're all common denominators, don't forget, you still have to figure out the non-permissible value. Okay, so that means x minus 3, that's your only one. You don't need the 2 up front because the 2 doesn't have a variable on it. Okay, bring the 3 over, you'll find out x cannot equal to positive 3. Oh, perfect, which is your non-permissible value. X equals to 3 is your asymptote. And you know what? Let's just, since we've got the graph right in front of us right now, let's put in that asymptote right there. There we go. X cannot equal to positive 3. There's my first asymptote. Now, do you remember what to do next? This will shock you. Remember, they're all common denominators. Guess what? You can cancel out the denominator now, right? This leaves you with x plus 3 equals to 2x times 2 times x minus 3 plus, oh, look what we have here, 2x. Oh my God, yeah, this is going to be tough. Oh, it's so hard. I know. 2x times 2 is 4x. X minus 3 is still not finished with that guy. We're going to expand this out, combine like terms. We're going to factor, and oh my God, yeah, you're going to be so impressed. This is going to be x plus 3, distribute, giving you 4x squared minus 12x plus 2x. Now, let's just do a whole bunch of combining here. Let's put it all together, and let's see what we get. Nothing goes with the 4x squared. Okay, minus 12x plus 2x is minus 10x. That's what you have here. And look what you have all over here. Beautiful. Bring everything over to the other side, making this equal to 0. So, of course, if it's equal to 0, guess what we're trying to find? The zeros. So guess what we're going to have to do? Factor. Oh, minus 10x minus x is going to give me minus 11x. Let's bring this x over to the other side. And of course, there's our wonderful 3. There's our minus 3. This becomes a PSA2. PSA2s are really easy because what you do, oh, can't see that very well. All right, PSA2 means you take the front guy and the back guy, you multiply them together. Okay, 3 times, or I should say 4 times minus 3 works out to be minus 12. There's your product of minus 12. Your sum has to be minus 11. Remember, in PSA2, you don't have an answer there. Two numbers together that multiply to give me minus 12 is minus 12 and 1, because minus 12 plus 1 gives me my minus 11. Okay, 4x squared minus 12x plus 1x minus 3. Group factor. Do you remember all this? This is all math 10. Take out a 4x. You've got an x minus 3. Take out a 1. You got an x minus 3. Bring them all together. You got 4x plus 1, x minus 3. Those all equal to 0. Boy, this seems like a long algebraic process, doesn't it? 4x plus 1 equals to 0. So x, doing a little bit of moving things around, a little bit of algebra, bring the 1 over, becomes a minus 1, divide by 4. This becomes minus a quarter. Whew! Holy smokes. And then this guy, of course, x minus 3 equals to 0. Bring the 3 over. X equals to positive 3. Wait a second. Wait a second. You're telling me one of the answers is x equals to 3. Why does this seem really, really familiar? Well, it's because non-permissible value, x cannot equal to 3. And you're telling me it is 3? There's an extraneous answer. Yes, this is extraneous. It's gonzo. Goodbye. So your only answer is x equals to negative 1/4, right? Or x equals to negative 0.25. All right. So let's prove this by putting this whole monster into my calculator. So just to make sure that I didn't mess up somewhere in my algebra here, folks, I'm going to go right back to the beginning, and I'm going to put the original question into my calculator. And of course, I'm going to put this part down as my y1. I'm going to put this mess down as my y2. Okay? All right, here we go. Calculator time. Oh my gotcha. So alpha F1. There's my fraction. Let's put my first fraction down, which of course is going to be x plus 3 over 2x minus 6. That's my first equation. Then my second equation is going to be plain old 2x. There's my 2x minus, then again, I need to put that nice little thing, that nice little fraction down again. Bada-boom, there it is. And I'm going to put down x, just as it was originally, before I did any algebra, okay, over 3 minus x. There we go. Okay, that looks exactly like what I had right back there. Do you remember? Okay, now I'm going to graph this thing, and it's going to help us out here to see what it looks like. Oh my, whoa my, whoa, that looks kind of nasty, doesn't it? Well, yeah, of course, but take a look at the one thing that you're looking for, which is that intersect point right there. Let's find that intersect. Second calc, find that intersect, which is 5. Look, my dot, my x, just happens to be right next to it. Okay, hit enter. There's my other one on the second curve. Hit enter, hit guess, and lo and behold, there's my answer, which I confirmed with my algebra. Now that just proves that your algebra was right. Oh my gotcha, how are we going to draw this thing? This thing looks just revolting. Well, a couple things we got to do here. We got to go back to the drawing board and check out a few things. Okay, ready? Here we go. Go back to this. Now, I just want to clean this up real nice first. Get all this stuff out of the way, okay? And let's take a look. First things first. Remember this guy? That was our y1, okay? Look at these two values. You got an x over a 2x, which means, guess what? Ha 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 ha. Your horizontal asymptote is 1 over 2. So you got a horizontal asymptote here at a half. So guess what? Let's put in our horizontal asymptote of a half right now. You also know that we have a vertical asymptote. Our vertical asymptote happens here and here. But if you remember, you took 2x minus 6 does not equal to 0. Bring the 6 over. X does not equal to positive 6. Divide by 2, divide by 2. And you know and I know x cannot equal to 3. right? You already knew that. You knew that when we drew this way, way back when. Same with this one. Look, 3 minus x cannot equal to 0. Bring the 3 over. You got minus x cannot equal to minus 3, so x cannot equal to 3 again. So you've known the vertical asymptote for a while now. Okay, now, remember our answer. Our answer was at minus a quarter. So our answer is going to be somewhere around this minus a quarter spot, right about there. That's where our answer is. Okay, but remember, that's the intersection of both those graphs. Well, let's start drawing our graphs then. Okay, look at the first one. Look at the blue graph. That's this guy right here. Look at that. That's why it's at a half. Look, look, look. There's our 1. There's our 1. Our half is right there. Look at that. And there's our horizontal asymptote. Oh my God, yeah, it actually worked out. So make sure when you're drawing this, because they're going to look for this, you got to make sure that you're slightly over the x-axis when you're drawing this. Zip this down, and it's going to go something like that. There's our first graph. Our second graph, of course, is going to be, or second part of the graph is going to be over in here. Confirm it by looking on your calculator. Yes, there it is. Now the red graph. This is the one that's going to be tough because it's actually going to have that wonderful thing we call, do you remember? An oblique asymptote. Yes. Oh my goodness, this is becoming confusing. And it's not. Let me show you why. Look, you know and I know it's going to come up to this guy right here. It's going to have some sort of oblique asymptote. You know and I know that it can't cross that line. Why? Because x cannot equal to 3. But you know also that it's got to go through that point. It's got to go through a quarter, which is right there. So that's going to help us draw an awful lot of this. So kind of eyeball it. There's our vertical asymptote. Look how this guy gets really, really close to each other. You see it? It's getting very, very close, but it doesn't equal to 3. It also goes through that point, looks like it goes probably through 0, 0, and kind of bumps up that way. Okay, so how do we do this? Real simple. We're going to go over here, and we know that it comes down around here, comes up to a certain value up here, but watch what that value is. If you look, that value looks like it's at about 2. It looks like it's at about 2. So right at about 2, oops, see, I drew this a little bit too long. Little bit too long. Let's get rid of that. Right about 2, it starts to bump. Okay? And then it starts to go downwards. And goes downwards like that. There's our second part of our graph. Holy smokes, that's intense. Absolutely intense. But what a beautiful drawing. What a beautiful answer. The non-permissible values in there. Oh, gotta love this question.